Okay, so here's the question. So these, we have 2x plus y equals 2, and we have 2x plus y plus 4 equals 0. Okay? We're doing this because I'm telling you, you need to know how to do this for your assignment, okay? You need to know how to like substitute or eliminate for the assignment. Okay? Okay, so let's I suppose, oh, these are solved by graphing. That's okay. We'll solve them like this first. So this number 1 wants us to solve these by graphing. I can give you some guys, or I can give you guys some graph paper. Okay, we can copy that before the end of the day, and you can just practice solving. But solving is solving, okay? So we can apply. It's okay that we'll. What do you want to use on this? Substitution or elimination? We'll do 2 questions. What do you want to do? Okay, why would you choose elimination? Just out of curiosity.
That's the one I can't do.
Oh, okay. That's one reason. Wesley? It's already perfectly lined up. What's that mean?
That means that
0 equals 0 is what Red is saying? It's a good. Well, I mean, yeah, it's a great. What's it mean though?
0 equals 0.
It means something though. In relative to the lines, it means something. It's good that we did this. I don't know if any of you have ever seen this yet. So it's good that we did this. Do you want to go here? Let's plot these 2 lines. Two x plus y equals 2, and 2x plus y plus 4. What happened? They're parallel. If you ever see 0 equals 0, you know they're parallel lines. So you can't solve it because they're parallel. It's good we did that. I don't know if we've ever done that or come across that before.
We've spoken about like the concept of 0 solutions equals parallel.
Yes, but not 0 equals 0. Like everybody, there are times where you get 0 equals 0 and you think you've done something wrong.
But is it 0 equals 0 though?
Well, you've eliminated both variables.
Okay, it can be 4 equals 2.
Or negative 4 equals 0 or something. You're right. Sorry. You're right.
No, negative 4 equals
Yeah.
2.
You're going to get a number. What Red is saying is if I brought the 2 over, it'd be like this. 2, so then you end up getting 2 equals 0. Which there's no variable to solve for, which means there's no point of intersection because the variables are gone. You know what I mean? So it's gone. Go.
So if there's no variables, is that always mean they're parallel?
Yeah.
Oh yeah. Oh my gosh, yeah.
It's good. Like this is the sort of stuff that we don't necessarily have the time for in this octomester pace to get into, but it's good that we stumbled on this. So part of the bigger picture. The bigger picture. Okay. All right, not a great question to start with. Well, it was a great question to start with, but in terms of substitution elimination, it's not. So let's go down to number 2, where it explicitly asks us to solve for substitution elimination. You can go back now after and graph. Okay. So let's do one question with substitution. We'll do one with elimination. Then we'll do some analytic geometry questions. Okay. So here, let's just. What do you want? A or B?
B.
Oh, good. You think B's harder?
No, B uses substitution.
What?
B uses substitution.
No, they're both substitution.
But this one is obvious.
Oh no, we don't do obvious things. That's the easy one. We do the hard ones. Okay, what now?
You might have to
Oh,
take this
yeah,
out.
we can't actually see.
Okay. 2A. Wait. Solve using substitution. Good? What are we gonna do? What do we need to do? We can't do anything right now. But if I get one of the variables by itself, like let's say y, I'm choosing y because there's a coefficient of 1 out front. So that's an easy one to solve for. So I'm just gonna subtract 2x from both sides, right? And so I'm gonna get y equals 2 minus 2x. What am I gonna do with that piece of information? Where else do I see a y on the page? Let's just throw it in there, see what happens. 3x plus 2. I'm going to input the yellow piece now. 2 minus 2x is equal to 5. 3x plus 2 times each of the pieces is 4 minus 4x equals 5. 3x minus 4x is equal to 5 minus 4. Negative x is equal to 1. X is equal to negative 1. Okay. Am I done? Remember what this is saying. It says solve. Solve means find the point of intersection, the POI, right? Every point ever that we've ever dealt with has a x value and a w. A y. We need a y.
Why though?
Why? Because math says so. I have a nice equation already that tells me what y is equal to. It's right here. Y is equal to 2 minus 2x. Plug it in there. Y is equal to 2 minus 2x. Y is equal to 2 minus, minus 2 times negative 1. Y equals 2 minus negative 2. Y equals 4. Point of intersection, negative 1, 4. Any crazies? Nothing? Nothing going on? That's all right, right?
So when you have the negative x equals 1, did you just divide both by negative 1?
Yes. Good. Divide both sides by negative 1. Okay? Yes?
For the y equation, you wrote y equals negative 2 times negative 1. Would it not be negative 2 times negative 1 instead of 2 times negative 1?
Same thing.
Either way you add,
You'll end up adding either way. But I'll do it that way, it's fine. You want to say, my issue with what you said there is I don't know what order of operation fills in the blank. Like what would go here if you took negative 2 times, you know what I mean? It turned to positive basically, right? So that's fine, like we can do that. You're basically going to get, what am I going to do here? What you're saying is y equals 2 plus 2. You know what I'm saying? Because you're taking a negative and multiplying by a negative, so it becomes positive. You still get y equals 4. Okay? You want to do an elimination, or are you okay? Let's do an elimination. 3, which letter, A or B? Oh, just one. This is a hard one, actually. Harder than it might need to be. Let's write the equations, okay? We're going to solve this with elimination. 3x plus 4y is equal to 17. 7x minus 2y is equal to 17. Okay? I want to solve this with elimination. Elimination, the premise of elimination is to eliminate one of the variables. I can't do that in their present state, so what are we going to have to do? And you can do this 100 different ways, right? You can make the numbers as big as you want. There's obviously a smart way to do it, and there's a way that's more work, but they will both work. Yes, Sarah.
Multiply 2 by 2, like that whole equation.
Okay, so Sarah's saying you're saying these are number ones and twos, right?
Yeah.
Okay, so number 2 by what?
By 2.
Okay. Sarah saying what's the matter?
Wouldn't you do it by -2?
No, it's okay.
Oh, because you just keep it negative and then add at the end.
Yeah, remember you can always choose whether or not to add or subtract there. Okay. Okay, so let's do what Sarah said. We'll multiply them by 2. We have 14x minus 4y is equal to 34. This is, we'll call this equation 3. Okay, and then what I'm going to do is write, I'm just going to rewrite equation 1 again. And look at that, that's nice. The 4's match up. So I'm going from -4 to 4, and I need to hit 0, so I'm gonna what? Not my best explanation. Are we gonna add or subtract here? -4 minus 4 is gonna equal -8, so I know I'm not gonna minus, right? I'm gonna have to go -4 plus 4. Right? To make these cancel. Right, so I'm gonna have to add the equations. Okay. So when I do that, I get 17x plus 0y is equal to 34 and 17. (44 and 7) be 51. Is that what you said? Very good. Okay. So x is equal to 51 over 17, which is equal to what? Okay, are we done? Can't write our point of intersection with just an x value. Gotta find the y value, right? How am I gonna find the y value? Pick an equation, plug in x. 7x minus 2y equals 17. Let's pick that one. 7 times 3 minus 2y is equal to 17. 21 minus 2y, 17. I'm gonna bring okay. Okay, I'll stop the video here and fast forward, and then we can talk about stuff.